Hey everyone, before we dive into today's video, I need you to do something real quick. Hit that subscribe button and turn on notifications because we're about to blow your mind with some seriously cool engineering. Did you know that steel, the stuff that literally builds our world, can be made from molten iron in just 20 minutes? Sounds impossible, right? Well, stick around because today we're breaking down exactly how the basic oxygen furnace makes this happen, and trust me, this process is way more fascinating than you'd think. Welcome to How to Hub, where we make complex topics simple and interesting. Today, we're tackling one of the most important technologies in modern steel production, the basic oxygen furnace. By the end of this video, you'll understand exactly how this massive piece of engineering transforms raw molten iron into the high-quality steel that's in everything from your car to the buildings around you. What exactly is a basic oxygen furnace? Picture this, a giant tank, lined with special heat-resistant materials, heated to an absolutely insane 1,700 degrees Celsius. That's hot enough to melt most metals instantly. Inside this furnace, pure oxygen gets blasted into molten iron, and something amazing happens. The oxygen reacts with impurities like carbon and silicon, creating what's called slag, basically the waste material that gets removed. What's left behind? High-quality steel with much lower carbon content, ready for whatever purpose it needs to serve. The story behind this technology. Let me take you back to the late 1940s. A Swiss engineer named Robert Dürer was experimenting with older steelmaking methods and had a brilliant realization. Instead of using regular air, which only contains about 20% oxygen, what if he used pure oxygen? Turns out, this simple change made the entire process way more efficient. Pure oxygen removed carbon from molten iron much more effectively than air ever could. An Austrian company picked up on this innovation and developed it further in the cities of Linz and Donawitz. That's actually why you might hear this process called the LD process. It's named after those two Austrian cities. Pretty cool bit of history, right? How does this actually work? Alright, let's break down the step-by-step process. It all starts with pig iron, which comes from a blast furnace. This molten pig iron gets poured into a ladle and transported to the basic oxygen furnace. Here's where it gets interesting. The furnace tilts at about a 45-degree angle, and workers load in the hot metal along with steel scraps. Then the furnace rotates back to an upright position, and that's when the magic begins. A water-cooled lance, basically a giant tube cooled by water so it doesn't melt, gets lowered into the furnace. This lance blows 99% pure oxygen into the mixture for about 20 minutes. Now, you might wonder why the lance needs to be water-cooled. Simple, without that cooling system, the intense heat would destroy it immediately. During these 20 minutes, the oxygen causes massive oxidation reactions. Temperatures soar above 1,700 degrees Celsius, melting the scrap metal and burning off carbon to create carbon monoxide or carbon dioxide. Silicon and other impurities also get oxidized. But here's the thing, steel isn't one size fits all. Different applications need different properties. That's why materials called fluxes, like burnt lime or dolomite, get added to the mix. These fluxes form slag that absorbs impurities, allowing engineers to fine-tune the steel's characteristics to meet specific industry standards. Modern furnaces use computers to automatically control chemical composition, temperature, and charging weight. It's a perfect blend of traditional metallurgy and cutting-edge technology. The final step is called tapping. The slag gets separated from the refined steel, and the molten steel gets transferred into ladles for further processing or casting. The whole cycle, from start to finish, takes roughly 20 minutes. That's incredibly fast compared to older methods. Two main types of furnaces. There are actually two major variations of this technology. The top-blown furnace is the most common. It uses that water-cooled oxygen lance we talked about, which blows oxygen down into the pig iron through 4 to 6 nozzles positioned at the top. The bottom-blown furnace, also called QBOP, is less common but equally interesting. Instead of blowing oxygen from above, it injects oxygen mixed with lime powder through tuyères, special openings, located at the bottom of the vessel. Key components explained. Let me walk you through the main parts of a basic oxygen furnace so you understand how each piece contributes to the process. The shell, this is the main body, made from incredibly strong and durable steel. You might wonder how steel doesn't melt at these extreme temperatures, and that brings us to the next component. The refractory lining. This special material lines the inside of the shell and serves two critical functions. First, it reflects heat back into the furnace, reducing the energy needed to maintain operating temperature. Second, it protects the steel shell from melting. Think of it as insulation on steroids. The water-cooled oxygen lance, as we mentioned, this delivers pure oxygen into the furnace while staying cool enough not to melt. The slagging hole, this is like a spout that allows workers to pour out slag when necessary, keeping the process clean and efficient. The tapping hole, when the steel reaches the desired quality, this hole opens to remove the molten steel from the furnace. How does this compare to other methods? You might have heard of other steelmaking technologies, so let's clear up the differences. Compared to the Bessemer converter, an older method, the basic oxygen furnace uses pure oxygen instead of air. This matters because air contains nitrogen, which can actually harm certain steel grades. The basic oxygen process is cleaner and more controlled. Compared to an electric arc furnace, the differences are even more significant. Electric arc furnaces primarily use recycled steel and melt it using electric arcs. The basic oxygen furnace, however, starts with molten pig iron from a blast furnace, though it also incorporates some recycled steel scraps. Different starting materials, different processes, but both produce quality steel for different applications. Why this technology matters? Let me give you three major advantages of the basic oxygen furnace. First, it's highly efficient. We're talking about producing massive quantities of steel in just 20 minutes compared to hours with older methods. That efficiency translates directly into meeting global steel demand. Second, the operational costs are relatively low, especially when working with molten iron that's already coming from a blast furnace. The infrastructure synergy makes economic sense. Third, versatility. This process can produce a wide range of steel grades, making it suitable for everything from construction beams to automotive parts to appliances. That flexibility is crucial in modern manufacturing. And there you have it, the fascinating world of the basic oxygen furnace explained in a way that actually makes sense. From Swiss engineer Robert Durer's innovation in the 1940s to the computer-controlled giants operating today, this technology has literally shaped the modern world. Every bridge, every building, every car you see, there's a good chance the steel came from this process. Now here's what I need from you. If you found this video interesting and learned something new, smash that like button. Seriously, it helps us create more content like this. Drop a comment below telling me what engineering topic you want us to cover next. I read every single one and your suggestions directly influence what we make. And if you haven't already, subscribe to How to Hub and hit that notification bell so you never miss when we drop a new video breaking down complex topics into digestible, interesting content. Thanks for watching, and I'll see you in the next one where we dive into another fascinating piece of technology that shapes our world. Until then, keep learning, stay curious, and remember, understanding how things work makes the world a lot more interesting.